so let's talk on the first page. You guys didn't ask about too many of these, but I do want to kind of recap something. If the original problem has an inverse, so when you start with an inverse, that's when we are limited to one answer. So that entire first page, every one of those had an inverse, so you can only get one answer. That's different than when we're solving equations with the trig function themselves. Remember, with the inverses, the quadrants were limited. You always had a positive quadrant and a negative quadrant. So it was either 1 and 2 or 1 and 4. So sine inverse, what quadrants did it work in? 1 and 4. Its reciprocal does the same thing. And what other trig function is in 1 and 4? Tangent inverse. So that means cosine inverse, its reciprocal secant inverse, and cotangent inverse are quadrants 1 and 2. You need to know that. So if the problem starts with those functions, you're going to write that down and you will only give me one answer. So if, for instance, I said, give me y equals arc sine negative radical 3 over 2.
That's the same as the sine of y. Inverse equals negative 3 over 2.
This just means give me the angle when sine is negative radical 3 over 2. Because it says arc sine, that means sine inverse. So you know it can only be 1 and 4. Since it's
positive and 1 is going to be quadrant 4.
Right, since it's a negative, we're going in quadrant 4. Reference angle, let's do degrees. When is sine radical 3 over 2?
60.
And 60 degrees in quadrant 4, so 360 minus 60 is 300. Okay. So we only get a single answer there. Now, one of the triangle problems. So specifically we had number 7, and we can do another one too. This says cosine of tangent inverse negative 1/5. All right, start on the inside. Tangent inverse, that represents an angle. So I'm asking you to find cosine of some angle. Okay, this piece means tangent of that angle is negative 1/5. Do we know when that happens? No, so that's when we draw a picture. Tangent inverse could be in which quadrant? 1 or 4. Because it's negative, we're in quadrant 4. Okay, so my angle comes out from the center. Remember, tangent is opposite over adjacent. So it would be, the opposite side is the negative side because it's going down. My adjacent would be 1. So then we do Pythagorean theorem. This missing side is the square root of 26. So now we have a triangle set up, so we can do cosine of that triangle. Cosine adjacent over hypotenuse, so 5 over radical 26. Get the radical off the bottom, so that's 5 radical 26 over 26. Want to do another triangle problem? Let's say I gave you tangent sine inverse of 1/4. this inverse represents an angle. And we have to find tangent of that angle. Do we know when sine is equal to 1/4? No, so we need a triangle. What quadrant would this be in? 1, because it's opposite. So sine is opposite over hypotenuse. A squared plus 1 squared equals 4 squared. So A is the square root of 15. So tangent is opposite over adjacent. So 1 over radical 15 should turn into radical 15 over 15. So the only time you have to set up those triangles is if you have both the trig function and the inverse in the same problem. Are those okay? So then we got into solving equations. Let's look at problem 9. Okay, so first, if it's just one trig function, we try to get it by itself, but we can't here because we have both sine squared and sine. So then we always check to see, is there a greatest common factor? But there's not. This one is a quadratic, so we can do easy method here. Sine squared would break into sine. What multiplies to a -3 and adds to -2? So then if we set each of those equal to 0, we get sine equals a +3 or a -1. Can sine be +3? No, sine can only be things between -1 and 1. So that one doesn't work. Can sine equal a positive or a -1? If you think about your unit circle, sine is the y. So when is y -1? And that's our only answer. If I said all possible, what would you put on the end of that?
Plus 360k and then you put k as an integer.
Perfect. Plus 360k, where k is an integer. If I say all possible and you're in radians, then it's plus 2 pi. All right. Let's look at problem 10. So I have multiple trig functions. We can get them on the same side. Now what can you do?
Sine 3 theta.
So then if we set each of those equal to 0, okay. Because it's a 3 theta, what do we know? Triple solutions. Okay, think about your unit circle for a second. Sine is y. When is y equal to 0?
When cosine is 1 or -1.
So this is at 0 degrees and 180 degrees. Then I have cosine 3 theta equals 1. So cosine is 1 at 0 degrees. Okay, you guys like to go ahead and get the extra solutions now, right? So we have 2. Because there's triple, we're going to get a total of 6. To do that, we add 360 to each of those. So 0 plus 360 plus 360. Okay, and we do the same thing here. So 180 plus 360 plus 360. And then you go through and you divide each one of those by 3. 0, 60, 120, let's see, 540 divided by 3 is 180, 240 and 300. So the last one had a 3 theta, so that meant we would have triple the solutions. What about when you have like x over 2? What does that mean? Yeah, check them. They may or may not all fall in the interval, okay? So if I'm going to solve this, I can subtract over my sine of x over 2. When you do that, you're subtracting exponents. So 3 minus 1 is 2. Sine of x over 2. So we divide by 2. All right, quadrants. When is sine negative?
Quadrant 4.
And,
Quadrant 3.
right, because it's not the inverse, we have to do every time. Reference angle. We are in degrees. When is sine radical 3 over 2? That's 60 degrees, right?
Yeah.
So our angle, x over 2, would equal, in quadrant 3, so 180 plus 60 is 240. In quadrant 4, 360 minus 60 is 300. So if you're getting x by itself, you would multiply the 2. So 240 times 2 is 480. 300 times 2 is 600. So those are the solutions. But I asked for the answers between 0 and 360. So what answers do I have between 0 and 360? None. So it's not that there's truly no solution. It's just there is not a solution between 0 and 360 on this one. Let's look at 13. All right. What problem do you notice here?
There's
2 different trig functions. We can't factor a Gray's common factor here. It's kind of like a quadratic, but we need it to be a single trig function. So look at your flip chart. That first one.
tangent squared minus 1 plus 1.
Tangent squared theta over 2 plus 1. So this is from our Pythagorean identity. And that was helpful because my other trig function is a theta, or is a tangent, excuse me. So I'm going to subtract over my 3. and combine my terms, we get tangent squared theta over 2 minus tangent theta over 2 minus 2 equals 0. So tangent squared, just be a tangent. Okay, what multiplies to negative 2 and adds to negative 1? So if we set those equal to 0, we get tangent theta over 2 equals a positive 2 or a negative 1. So now we need to solve both. Tangent theta over 2 equals 2. In what quadrants is tangent positive?
1 and 3.
Reference angle. Do we know when tangent is equal to 2? No. So we need a calculator. We need to be in degree mode. And so then we can do tangent inverse of positive 2. We get 63.43 degrees. So our angle, which is theta over 2, could equal, in quadrant 1, your reference angle and your angle are the same. In quadrant 3, you would do 180 plus that. Okay, now let's talk about the other one. When is tangent negative?
At 45 degree quadrant 2.
And then reference angle, when is tangent 1? So 45 degrees in quadrant 2, 180 minus 45. Is, and in quadrant 4, 360 minus 45.
350.
So do we have double or triple solutions or anything on this one? No, because my angle is theta over 2. So to solve, you take each of these times 2. I mistyped that. Okay. Are all of these going to be solutions? No, I only asked for the ones that were between 0 and 360. So that's 126.86 degrees and 270 degrees. Those are the only ones in the interval we needed. Let's try another. So you guys were good on 14? All right. What's wrong with this one?
Different trig functions.
We have different trig functions and
The one's got a 2, the other doesn't.
right, one's 2x and one's x. So we really can't do anything unless our angles match. The 2x would tell me double solutions, but the other one doesn't have a 2x. So let's go to our identities. Cosine 2x, that's a double angle, so we could replace it with something.
1 is sine 2x, I think, isn't it?
Minus 2 sine squared x.
Yeah.
Okay, you have 3 options. We chose this one because it was a sine x on the other side. So, if I want to solve this, we need to get everything on one side. two things that multiply to a negative 2 and add to a positive 1. So that would be 2 sine x and negative sine x. So 2 sine squared x and 2 sine x, what could you take out? Negative sine x and negative 1. Take out the negative 1. And take out sine x and positive 1. So if you set those to 0, you get sine x equals 1/2 and negative 1. So quadrants, when is sine positive? Reference angle. When does sine equal 1/2? We are in radians now. So our angle is x. Pi over 6 in quadrant 1 is pi over 6. In quadrant 2, that would be 5 pi over 6. Over here, when is sine negative 1? So that's like saying on your unit circle, when is y negative 1? Y's negative 1 is right there. So 3 pi over 2. Since this is just x, those are the answers. About 16. That one had a lot of solutions. Do we need to go through that one?
We can do something similar.
Okay. We'll go ahead and work through 17 then, and then I'll throw up some other problems. So for this one, it's already solved for me. Do I know when sine is 1/4? No, so we'll have to use the calculator. Quadrants, when is sine positive?
1 and 2.
Reference angle, we need to know when sine is 1/4. So first of all, we are in radians, so flip your calculator into radian mode. And then you need to do sine inverse of 1/4. You get 0.2527 if you go to that many decimal places. So our angle is 2x. In quadrant 1, the reference angle is the angle. In quadrant 2, if we're in radians, we have to do pi minus the reference angle. But because it's a 2x, what does that tell me?
That's double solution.
Okay, so to get the remaining ones, what do we do to each of those?
We add 2 pi.
So then, to get x, we divide every one of these by 2. So, 1, 2, 4. So we get a total of 4 solutions. Alright, so the first one. Both of these are 3 theta, which which tells us what?
Trig solutions.
Okay, but the trig functions are different and we can't factor them. So what could we do instead? So that's cotangent squared 3 theta minus 2 cotangent 3 theta plus 1 equals 0. So cotangent squared breaks into a cotangent. What multiplies to 1 and adds to negative 2? Negative 1 and negative 1. So if you set each of those to 0, they're the same, so we really only have to do it once. So we just have cotangent 3 theta twice equals 1. So quadrants, when is cotangent positive? Reference angle, when is cotangent equal to 1? Which in radians is pi over 4. So 3 theta would equal, in quadrant 1, pi over 4 is pi over 4. In quadrant 3, that would be 5 pi over 4. But we know there's triple solutions, so each of these should give us 2 more. How do we get those? So we get 2 pi is like 8 pi over 4, so we get 9 pi over 13 pi over 4, 17 pi over 4, and 21 pi over 4. And then what do you do to each of those? We'll multiply by a third. So you get pi over 12, 5 pi over 12, 9 pi over 12. Yes, thank you. 17. 12. Is that okay? Let's look at this one. And let's say, I said in radian, let's specify only answers between 0 and 2 pi. So if we get extras, we're going to throw them out this time. What would I do here? Okay, quadrants. Tangent's positive and do we know when tangent is 3/5? Okay, so we need to be in radian mode and tangent inverse 3/5 is let's just do 0.38. So x over 2. In quadrant 1, 0.38 is 0.38. In quadrant 3, you'd have to do pi plus 0.38. So we get 3.52. And then to get x, what do we do to each of those? So we get 0.76 and 7.04. I told you to give me everything between 0 and 2 pi. 2 pi, if you put that in your calculator, is 6.28. So the only answer that would be in the